Good morning, this is Dr. Turner for Integrated Math 2. Today we're going to be covering 9.2, which is looking at the rotation of two-dimensional solids. This is a more difficult topic to comprehend because we're looking at two-dimensional shapes that we're in theory rotating in a three-dimensional space, but we're doing it on a two-dimensional surface like paper or on the computer. So it's a little tricky, a little bit confusing, but once you do it a few times, hopefully it'll sink in. But let's go ahead and just jump right into it. So in this section, what we're doing is, again, rotating two-dimensional shapes in a 360-degree space, and we're trying to represent that on a diagram. So what this looks like is we're going to take a shape, and we'll start out with, let's say, a triangle, and we want to be able to rotate this shape in some direction. And it'll specify in the directions which way we're supposed to rotate it. But the idea is, let's say we took this shape and we were able to spin it really fast, faster than the eye could comprehend. What shape would it generate? And so with a triangle, let's say we were looking at this on an axis, and I asked you to rotate it about this vertical line here. Okay. So if I were to rotate it, and you can sort of do this by hand, but if I were to rotate it, say taking this corner, and I rotated it all the way around, again, able to spin it really, really fast. It doesn't matter which direction I'm rotating it. It could be clockwise, it could be counterclockwise. But what we would end up generating is a cone. Now, that may be confusing, but again, take that triangle and imagine you're spinning it really fast, right? That would generate a cone. For all of these problems, that you're going to have some type of curved surface, and that's important too to recognize. For all of these, we just got done talking about, let's say, a cube, and we talked about cross sections, we talked about nets, but for rotations, all of the shapes generated are going to be curved surfaces, curved three-dimensional objects. So most commonly, we're either going to get a cone or we're going to get a cylinder, right? In this section in 9.2, none of the answers are going to be rectangular prism. None of the answers are going to be cube. It's going to be some type of three-dimensional shape with a curved surface. Now, with the triangle here, it doesn't matter on which axes I'm rotating it. So, for instance, if I wanted to rotate it along, let's say I had the x-axis drawn here. If I had the x-axis drawn and I was rotating it the other direction, in theory, I should end up with the same type of shape. So again, rotating it around the axes, trying to imagine a three-dimensional concept in a two-dimensional space. That would go around the axes. Okay. Again, it doesn't matter which way I'm rotating it at. And then that would create, once again, a cone, but oriented the other way instead of oriented up. Okay. That's the idea behind 9.2, being able to identify what shape is created by these rotations. In the PowerPoints and in the supplemental resources, you have some computer-generated examples that are a little bit neater if you want to use those as a reference. Continuing on, let's go to the example we were just talking about with a rectangle. Now, when we think rectangle going from 2D to 3D, a lot of students, their knee-jerk reaction is going to be, okay, that's a rectangular prism. But again, with these types of problems, with rotations, all of the problems are going to generate a curved surface. So just like with the triangle, it doesn't matter which side I'm rotating it about. Let's again go with that example of the vertical. So when I spin this around, I'm going to end up with a side over here. The other two sides are going to stay the same. So the top and bottom, those are going to be at the same point here. And then again, what that rotation does is it creates a circular surface. So this side is going around 360 degrees. Same thing at the bottom. It's going around 360 degrees. So in that case, it's generating a cylinder. And the same would be true if I was rotating it about the y-axis. So again, there's no rectangular prism here for 9.2. There's no cube here for 9.2. All of the shapes have to generate some sort of three-dimensional shape that has a curved surface. Okay, so these are the majority of your questions. You're also going to have problems involving a circle. Now with a circle, this one is a little different. With a circle, if I ask you to rotate it about, let's say its diameter, and it doesn't matter if the diameter is vertical or horizontal. But when I rotate it, and let's say I do rotate it around a horizontal axis, you end up with a sphere. Now that is generated by rotating that circle around a line that is going through it, specifically rotating it about its diameter. With a circle, there are also questions that ask you, what happens if you rotate the circle? But let's say you're rotating that circle around a line that is not on its diameter. So let's say I'm rotating it about this line over here that's off of the circle. Well, in that case, you end up with a different type of shape because you're rotating it about a line that is not on the shape. And the circle is going to be the only one that has an example like this for us right now. But if I wanted to rotate it about this shape, what's going to happen is I'm going to end up with a different kind of shape. So taking that circle and again trying to imagine a three-dimensional concept in a two-dimensional space, the circle would continue to rotate around and around this line, and when it does that, it's going to generate a shape that looks something being the keyword, something like this. So it's going to go around and back around, and in the center it's going to go around and back around. What you end up with here is actually, and I'll try to draw the lines a little bit neater here, but you end up with a donut type shape. So imagine you took that circle and you rotated it around 360 degrees. You end up with a donut. Now the donut is an informal term, and if you guys use it for the assignment, that's okay. I'm not going to dock you for that. However, the more proper name for donut the more proper name for donut is a torus. Deleted my my shape here. Try that again. Okay. So the more proper name for that is a torus, and again, you can see a more neat example on the PowerPoint or the supplemental resources. So donut informally or torus is the proper name for this. I'll accept either for the assignment, but that is 9.2. If you guys have any questions, please reach out to me. Otherwise, have a good day, and I will talk to you soon. Bye.